This is Taylor Swift's The Eras Tour Calorie Expenditure 3 tracker. I've been a Taylor Swift fan for as long as I can remember, and the Eras Tour that she just did is the highest grossing tour of all time, which surpassed over $1 billion in revenue, and over 10 million people attended. Because I've taken classes related to diets, and I now have the ability to calculate her caloric expenditure, I wanted to figure out how much food and water it takes to fuel her for one night. Through this, I learned that it's very difficult to calculate an accurate energy expenditure through a recording of physical activity alone. There's so many variables to account for, and a couple different ways to go about calculating it that lead to different results. Live performances are an easy way for people to connect with other fans, and a lot of people think that it has to be either STEM or art, but I wanted to show through this project that it can be both. So using this to calculate her caloric expenditure, there are two ways that we could do it, which is mechanical calculations using tracker software data, and then MET calculations, which are a more real-world solution. Going in, we already know that she's about 74 inches, she's about 54.4 kilograms, and that the show is 3.25 hours long. So for the data collection for the mechanical calculation through Tracker, I found a somewhat stable video of one full song of Shake It Off from the Eras Tour. I uploaded it into Tracker, and I set the calibration stick for her height of 74 inches and the point of origin so that every move she made had a positive X and Y value, as you can see over here. I set the frame rate to 10 frames a click, and then I tracked the center of her torso, which gave me positive X and Y and provided the total length traveled and velocity. So she moved about 203.2 meters. She's 54.4 kilograms. The show, one song of Shake It Off, is 0.058 hours. And then we also know that gravity is 9.87 meters per second squared. 1 kcal is equal to 4,184 joules. And we were able to calculate the average speed using these graphs over here, which is about 0.9676 meters per second. This is a lower bound conservative estimate, which ignores specific things such as limb work, heat, and breathing. And then so we found the instantaneous kinetic energy using the average speed, which is 1/2 mass velocity squared, which is about 25.47 joules. Looking at the K versus T graph, estimating about 200 bursts of energy, which are all the peaks in this one. We found that it's about 5,094 joules, and then accounting for muscle efficiency with a mid-range of 25%, we find that it's 20,376 joules for the one song, and then converting this to kcals, it's about 4.87 cals for one song, with a range of 4.06 to 6.09 calories for the song performance. Using this, we know that the show is about 56 songs, which, multiplying that by what we just got with an average of 5 cals, it's 285 cals for the whole show. So this would be, for one song, it would be the equivalent of a single baby carrot, 1.6 M&Ms, or 1 tablespoon of Gatorade, and for the whole show, it would be 1 granola bar or 1 slice of pizza. For the MET calculation, this process was more simple than using Tracker, as it just needs the RD information of time, mass, and MET value, which stands for metabolic equivalent. For the MET estimate of a performer, the range is about 6 to 8. So this is MET times 3.5 times mass times time divided by 200, and for the whole show, it's 1,301.87 calories. For a single song, it's 20.03 to 26.71 calories, which is a medium-sized grape, a cup of cucumber, or a medium carrot. For the whole show, it's 1,150.89 or 1,487.85 calories, which for the whole day would be a slice of avocado and egg toast, a cup of cucumber slices, stuffed salmon avocado, an orange, and salmon with asparagus. For water, the average is about 0.8 to 1.2 liters an hour with an average of 1 liter, so for a full show it's 3.25 liters, but to fully recover, athletes should take in 150% of what they lost to account for things lost in urination, which is 21 cups for a full run through. Then we have just the summary of the values that it would take for her to consume. The best footage I could find for the song performance was at an angle, which would account for some uncertainty and error because the camera would move and it would move where she was on the chart, on the graph. The MET calculation had a range because it's hard to know how much effort she's actually putting into her movements. And for water, I don't know her physiology, the room temperature, or the breathability of her outfit, so that could be a little off. I was also only realistically able to calculate the movement of one song because a whole 3.25 hour show is kind of a long time. I was not able to account for the different planes of movement, and mechanical energy calculations appear to be an underestimate of what realistically would be used. So for my class problem, it's about the same scenario but different numbers, and then we've got the solution here, and then we have my art of I overlaid the movement of her on the Eras Tour stage, and that was the end of my presentation, and these are all of my sources that I cited. Thank you.